All right, so once you have the section kind of roughed in, I would go back and forth and work on those details. So this is the section, and this is the first series of R values that I'm going to be calculating. Again, I'd go kind of back and forth between the two, between your section and the figuring out the R values for it. Because if your R values are too low, then you're going to need to go back and change the section to reflect a drawing that would have higher R values. So if I'm doing part 2 of this assignment, or step 2, I'm looking at that. And when I look at the outside, I'm going to have an outside air film, then I'm going to have my siding, there's an airspace, then I have an insulation, which is an extruded polystyrene. Then I have either typically 2x4 or 2x6 wood framing. And then on the inside, I'm going to have 1/2-inch gypsum board. And that cavity is going to be filled with whatever type of insulation you decide that you're going to use. So in the calculation that I've set up, I'm looking at, here would be that larger detail drawing, and for each of those elements, I'm calculating the R value. So I'm going to have that outside air, the wood bevel siding, 3/4 inch airspace, 1-inch extruded polystyrene, and then I'm going to go with the 2x4 with blown cellulose, 1/2-inch gypsum board, and inside air film. And in the handout that I gave you as part of this assignment, you will see some tables, and it is going to have R values for common building materials. So it's broken up into insulation materials being this first section, then a variety of other construction materials. Here you have sheathing, siding, interior finish materials. Then you have roofing materials, windows, doors, and air films as kind of that last category. And so when we're calculating the R values for those different materials, the first thing that we had was the outside air. And the outside air film, if you look at this, you have it broken down into summer and winter, and we're looking at heating, so we're during winter conditions. So this would be interior wall, and then the exterior wall, the R value that you have associated with that, that air film is 0.17. So the first R value on the sheet is 0.17. And that would be consistent for the rim joist and the exterior wall. For the ceiling, you need to look at the interior ceiling horizontal. And then for the inside air, we'll talk about that in a minute. So the next portion that I need to find the R value would be for wood beveled siding. And so I'm going to go back to that R value. And in this case, I'm looking at wood bevel lapped siding. And so the R value in this case, if you look at it, it's broken down into an overall thickness or per inch. And so you need to keep that in mind when you are looking at the calculations for this. So the wood bevel siding has an R value of 0.080, and then the airspace, anything that is between 1/2 inch to 4 inches is going to have an R value of 1. So that's 1.0. Then I have extruded polystyrene, and that has an R value of 5. So if I look here, the R value per inch is 5, and I have 1 inch of that. So that's 5 there. And then I have 2x4, a 2x4 framed wall with blown cellulose. Now keep in mind that a 2x4, that's nominal dimension. That's really 1.5 inches by 3.5 inches actual dimension. and 2 by 6 is 1.5 by 5.5. So even though it says 4 inches, when you're doing your calculations, you need to use the actual dimensions for that. So if I'm using blown cellulose insulation, you need to go back to the insulation numbers here and look at, in this case, the wall value, and it gives me a range for that. And so I need to take the average. And so the average for that is going to be 3.85. So in any of these you add those two numbers together and then divide it by 2 in order to find the average. So that is per inch, and I have, in this case, a 2 by 4, so I have 3.5 times the 3.85, and that's going to give me 13.47 for the insulation that's in the cavity. So 13.47, and then I find the gypsum, or the 1/2 inch gypsum board here. And so in residential we use 1/2 inch thick gypsum board, and in commercial we would use 5/8. So our R value is going to be 0.45, and then that inside air film is going to be 0.68. And so when I add those values up, I would get 21.57 for my total R value for the wall. And you're going to go through this process for all 4 of those scenarios. And so I would go back and forth between kind of calculating those R values and then that section to get those two things that are correlating to get those values. So the first 2 parts of your assignment, when you look at that, I'd have sheet number 1, and that would have the wall section with everything that's required on it. The second sheet that I would see is going to have the R values and a detail. And that would be for the roof, the wall, the rim joist, and the basement. Those are the critical areas when we are determining that thermal envelope. So that's our second sheet that you're going to be required. And those details, I would say roughly 1.5 inches is equal to 1 foot. Wall section, 3/4 of an inch is equal to 1 foot in terms of scale. Those are at least typical scales for drawings of this. You can always do break lines if you need to break up those long distances, similar to what I did, or what I am showing you here in that wall section, in this wall section here, where you have all of those pieces. Sometimes those break lines are there to be able to allow it to be drawn to scale but still fit on a sheet.